This is Unit 2, Lesson 3, Day 1. The topic we're going to be talking about today is linear regression. So we're going to be dealing still with these linear functions. The difference is it's going to be based on a table of data where things don't necessarily fall right on a perfect line. We're still going to be able to use something that's linear to approximate where the data might be headed. So the first thing we're going to look at is a scatter plot, which I know you guys have definitely seen in Algebra 1, maybe even in geometry. So scatter plot shows the relationship between two variables. There are three of those possible correlations. Positive correlation means as one variable goes up, the other goes up, which means as one goes down, the other goes down. So wherever these points are, when you plot them, the trend is that they seem to be headed up, like a positive slope like that. Negative correlation is just the opposite. You see this trend where you've got this downward movement in the points. Looks something like that. And then no correlation, there really isn't any sort of pattern happening at all. You've just got these random points kind of all over the place, and they don't really seem to be going up in any sort of pattern or down in any sort of pattern. So those are your three relationships that you might have. We're going to be making a scatter plot and then talking about something called the line of best fit. The line of best fit is a linear equation that gets as close to all of the points as we possibly can. Now, something like this, these points don't fall right on a line, so it's not like it's going to hit all of the points as it goes through. It's just going to be the best possible match for all of those points that we're able to find. So we have one example here. It says this is the relationship between the depth of a lake and the water temperature in degrees Fahrenheit. So you can see over on this table here, we've got different depths. So this is like from the surface of the water going down this many feet, and then this is the temperature. So you can see as the depth increases, the temperature is decreasing, which makes sense. Think about a lake. The deeper you get in a lake, the colder it would be. So we're gonna make a scatter plot. So what we do, we are gonna label our axes first. So D is the first variable, so it's kind of like the X. So that's gonna go here. So we're gonna label that D. And then T is the second variable, so that's kind of like your Y. So that one's gonna go here. So we label anytime we make a scatter plot. And then we wanna make sure that everything is scaled appropriately. So here we need to make sure we can get from 0 to 15. So there are 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15. Oh, perfect. Okay, so that one we can just scale by 1. So every mark is just gonna be 1 unit on that axis for D. This one, we definitely can't do that. But one thing we can do, since they're all kind of compacted in here, we can do this little, it's like a little squiggly thing that we can do. And that shows that you're cutting off a certain amount of values. So we're gonna cut out a certain amount of values, and then let's make this one 75. And then we'll just go up by 1. All right, so this little squiggly means I'm cutting out everything from 0 to 75 and just picking up there. So 0, 85. So 0's right here, so if this is 75, then we've got 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. So that's the first point. And then we do the same thing with all of these. So 4, 82. So 1, 2, 3, 4. And then up, remember this is 75. So 76, 77, 78, 79, 80, 81, 82. Next one, 7, 81. So this was 4, 5, 6, 7. And we know if this was 82, then 1 below that must be 81. Next, 10, 79. So from 7, I can go 8, 9, 10. And from 81, I can go 80, 79. All right, then 12, I can go over 11, 12, and down 78, 77, and 15, 76. So 13, 14, 15, down 1 to 76. So those are my points. You can see that there's definitely like a negative trend as it goes through. And so part B, we're gonna do something called the line of best fit. So we are gonna pick any 2 points that we want, and we're gonna figure out how to make a line out of those points. All right, so if you kind of look and see what looks like it might be the most in the middle, so I'm gonna have a straight edge so I can, grab a notepad here. So a straight edge so I can see a good line, what this would look like. So this looks like if I go from end to end, it's actually not a bad, so if I just connect the first point and the last point like that. So that's not a bad fit. So 2 of these are right on the line, 2 of these are above, and 2 of them are below. So that's a pretty good match because you kind of want it going right down the middle. So when I say 2 ordered pairs, you could choose any 2 you want. I'm just going to choose the beginning and end. So the first point is 0.85, and then the second, or the last point that I'm going to use is 1576. So I'm going to write a line of best fit, and this is what I did a couple lessons ago when I had 2 ordered pairs. I would find the slope and then use that to set up an equation. So I'm going to find the slope first. So slope is change in y, so 76 minus 85 over change in x, so 15 minus 0. So we calculate that. So we have 76 minus 85, and that is -9, over 15 minus 0 is 15. So that's not a reduced fraction, so I want to reduce it down, and I can reduce by a factor of 3. So -3/5 is what that will reduce down to. So now I know the slope. So remember the equation that we were working with was this. This is our point slope form. So this is kind of the generic equation, but remember, I'm not using x and y anymore, I'm using d and t. So t was like our y, so we're gonna make this t minus t1, and then d was like our x. So this is gonna be d minus d1. So I can plug some ordered pairs in there. So I have t minus my first value of t, which was 85, equals the slope, which is -3/5, and then d minus the first value of d, which is 0. So we get that plugged in, and then I can calculate. So if I distribute this -3/5, it's just -3/5 times d, and there's nothing to multiply by with the 0, and then I just add the 85 over to the other side. So looks like that. So that's my equation that they wanted me to come up with for part B. For part C, it says predict the temperature of the lake. So we want to find T at 25 feet. So that is when D is equal to 25. So they're asking me to get an approximation for T when D is equal to 25. So I'm just going to take that 25 and plug it in right here. So we'll have T equals -3/5 times D. So I'm plugging in the 25 right there, and then plus 85. So this, I can reduce this down. I have 25 over 5, which is 5, times -3 is -15, and then plus 85. So when I add those together, I end up with 70, and remember that is in degrees Fahrenheit, so you want to include your units. So that's the first way. That's how you kind of calculate everything by hand. We're going to learn something more formal called linear regression. So this is finding the best fit by using a calculator, and the calculator runs all these sorts of formulas and everything for you. This bottom part, these are directions for using an actual graphing calculator. I'm assuming that most of us probably do not have that. So we're going to kind of ignore these directions right here. We're going to do everything on Desmos. All right, so I would like if you could kind of follow along here while you guys are watching, because the more you practice, the more these steps will make sense. So we're going to look at a couple of examples on the next page. So we're going to start with number 1. Like I said, we are going to use Desmos to plot this data, and then we'll come up with our regression equation. So open up Desmos. Like I said, I would like you to do this with me so that when it comes time to practice, you actually know what you're doing. All right, so we see this data that we're going to be working with. So you're going to have just your blank box over on the left-hand side in Desmos here. There's a little plus, so we're going to press this little arrow, and you're going to add a table. So that is what we have on the middle here. So we're going to add a table. Up at the top, instead of x1 and y1, we want to change those. Oops. Change that to P, so you can go to the alphabet, change that to P, and change this one to S. And then we'll line everything up down here. Okay, so P, back to the numbers, we have 63, then you can press this little arrow to go down. Next one is 115, go down. 153, it'll try to make predictions for you, that's what that number was. 192, next is 224, 297, 331, and the last value for P is 375. So we get those, and then I'm going to scroll back up to the top and fill in S. So we start with 112, so I'm just putting these values in. 209, 278, 302, 379, 500, 586, and the last one is 712. So that's my table. So I've got everything filled in, and when you're doing your homework and stuff, you want to do a quick scan, make sure that all the numbers line up. So then here's what you do. You click in the next box underneath where the table is. So you should have this blank box pulled up again. And now we are going to write an equation for our y equals mx plus b. Okay, so our regression equation, normally it would be y equals mx plus b, right? Like, you know, just the normal equation for a line. But instead of x, we have a p, and instead of y, we have an s. So it's going to be s equals m times p plus b. So the p replaced the x and the s replaced the y. So that's the equation that we're going to type in. And here's what you're going to type into your into Desmos. So we're going to start with the s, and then there's this little squiggly sign that I'll show you how to make, or I'll show you how to type in. What that little squiggly sign does is it makes the regression. Okay, and then we just type mp plus b. So we're typing this right into the calculator. So let me show you how to do that. So on the alphabet, we're going to press the S. And then you can see down along the bottom row, we've got a couple symbols here. The little squiggly sign is right under here. Looks like it's right around like the B and the N. So press that. And then M times P. We'll have to jump back here to get the plus sign. And then back here to get the B. So when we do that, then we can scroll and see these. This is what we're interested in. These are called the parameters. This is a value for M and for B. So I'm gonna write those down. So let me see if I can keep it up on the screen here so you guys can still see it. So we have S equals, so M is 1.83428, that's the slope, times P, and then B is minus 16.4978. So that's my regression equation. All right, so that is a slope-intercept form for the best possible fit that's gonna run right through the middle of this data. Okay, we've got our y-intercept and our slope just like normal. Then it says predict the number of suitcases on an airplane with 500 people. Okay, so this is what we're gonna plug in for P, and then they're asking us to predict the number of suitcases. All right, so we have S equals, we're gonna plug this in, 1.83428. We're plugging in 500 for P, and then minus 16.4978. So there's a lot of decimals and stuff, but you've got a calculator, so we can just plug in exactly what's written there. So I'm gonna type in another box right here, 1.83428 times 500, and then minus 16.4978. So the prediction they're giving me is 900.6. So I'm just going to round that up to 901. So 901 suitcases. So that is my prediction, which kind of makes sense. If the people kept going up, the number of suitcases would keep going up. So based on that, that's what they are predicting. All right, let's look at one more. We're going to look at number 3. The first number 3, I guess they're both labeled. The table below shows the salary in millions made by the highest paid Major League Baseball player during certain years. So we've got the year, we've got the salary. So we're gonna type everything in. I'm gonna clear out what I've got so far on Desmos. I'm gonna make a new table. So I'm gonna go through a little faster this time. So we're gonna add a table. I'm gonna make this Y for the year. And I'm gonna make this S for the salary. Type all of these values in. Oh, it's not going to let me. They don't want me to use Y. I'm going to use T for time then, I guess. All right, so we've got 1985, 1991, 1993, 1996, 98, and 2001. So then back up here for the salary, we have 2.1, 3.8, 6.2, 9.3, 14.9, and 22. Okay, so that's all our data. So we're going to type in an equation just like this, but instead of y equals mx plus b, we switched up our variables. So instead of x, we are using t, and instead of y, we're using s. So it'll be s equals m times t plus b. So when we find our regression equation, we type s, and then the little squiggly, and then m times t plus b. So I'm going to type that in so I can figure out what my regression equation would be. So in the next line down here, I'm going to type in s, then a little squiggly, m times t back here for the plus sign, and then b. So when I type that in, scroll down a little bit, these are, whoops, that wasn't on the screen. These are my parameters. So I can write that down here. S equals 1.22312, that's the slope, times t, and then minus 2429.19, that's my y-intercept. So that's my equation, my regression equation. And then answer their follow-up question, predict the salary of the highest paid player in 2020. So this is what I'm going to plug in for t, for time, and they want me to figure out what s is. Okay, so I have S equals, and I'm just taking these exact numbers that I have over here on the left, replacing t with 2020, and then I'll just be able to plug that right into my calculator. All right, so I'm going to take this whole thing and just plug it in. So I have, back to the numbers, 1.22312 times 2020, and then minus 2429.19. So this one I did have a tenths place, so I'm going to write it as 41.5. So just kind of keep in line with what the rest of the table is giving you, and that's why I want to use 41.5 because all of these use the tenths place. So this would be 41.5 million.